Hello everyone. So welcome back to our first live tutorial on multivariable calculus. So in this tutorial, I'm going to take you through domain and limit of multivariable functions. So that will be the first lecture in this particular course. So as I said, this course is calculus with several variables. Calculus with several variables. So to begin with calculus with several variables, as I said, we are starting with domain and limit of multivariable functions. All right. Yeah. So let's get set and let's see how best we can go by this. So let's get set. I will entreat you to take your book and also your work alongside as we begin this particular tutorial. Okay, so let's see. What do we mean by multivariable function? So in our previous years, we've done calculus with single variable, right? So first of all, I'll take you through the term function once again. So what is function, right? So let's hover around functions, then we move towards what a multivariable function is. A function. Okay, so when you say a function is anything that takes in an input and brings out what? An output, okay? But within this input and output, there is a big gap here, right? And this gap here signifies something. I mean, this function, so this is where the function takes place, okay? So a function is just a black box that takes in an input and brings out an output. So the function manipulates an input, so it massages it, or the function adds something to the input, then also produce the output. Okay. So right now, assuming that I have a function which multiplies what an input, so that's the meaning. So the function will be what 2x, and it will take in an input as what x, right? And it will produce what we call y. So meaning that this function can be modeled mathematically as y is equal to 2x, right? Meaning that if my input is 1, the function will multiply 2 by it and I'll get output 2, right? So that's the concept of function, okay? So it's perform a specific task by receiving an input and also bringing out what an output, right? Yeah, so at this point, there are some few things for you to consider about functions. When you say a function should produce, so it should produce a unique output, okay? So every function should produce a unique output. That is the key term here. It should produce a unique. So only one and only output. That is it. One and only one output. Irrespective of what you feed it into it. That should be a function. Once anything produces more than, so if you have any function, it's giving you more than one output, it means that it doesn't qualify to be called a function at all. Okay. So as it produces a unique output, it also receives at least one input, at least one input. Okay, it receives at least one input. So a function will take in can take in what one input, can also take in what more than one, but it should produce what a unique output. That is what you should take note of. It should produce one output. Should produce one output. So now let's see. Once I have explained this to you, meaning that we can have a one-to-one function, one to what one function, right? Then we can also have many to one. So these are the two types of function we can what get. Many to what one. Is that not it? Function. So in calculus one, when you're doing calculus with a single variable, okay, or calculus with analysis, that one you are using only one variable, so that fell under this category, one to one function. But in calculus with several variables, we are going to deal with what many to one function, okay, many to one function. This function will take in several inputs, and after it will bring out what some what output. I mean, it will bring out a unique output. Okay. So the only difference between this and calculus with single variable is that this is taking in more than one variable. So if in the single variable we're having f of x is equal to 2x plus 3, with several parables. When the word several is just a plural word, right? So several can mean that two, several can also mean what three, can mean what four in that order, okay? So you can get a function f of what xy, which is equal to 2x plus what y. You get it. So this is a typical several variable function, okay? A typical several variable function. So we can also have a function that will be taking in what three inputs, okay? We can also have a function that will be taking in three inputs. So we can have a function like f of x, y, and z is equal to, let's say, 2x plus y plus what z. So this function is taking in what three inputs. And what it does is that once it takes the input, it will multiply the first one by 2 and leaves the other and add the two together. So this is what the function is doing. You receive three inputs, and this is the operation it will perform on the input to give us what a specific what output, which will be what the function. So normally we represent it with what maybe any variable, okay, but not this one. I use y, so I can't use y to represent it. So this is a brief overview of a multivariable function. A brief overview of multivariable function. So now let's see, when you start, when you are having a single variable, a function which is taking in a single variable and putting it and bringing out another single output, okay, that one we are going to deal with what the plane. You can do with what xy plane. So this will be the x, right? And this will be the what y. Is that not it? So once you have the 2 by 2, meaning that the function as it takes in what an x value, it will give what a single y value. Is that not it? As it takes in another x, it gives another single. It takes in another x, it gives another single in that manner. So this is what we call the two-dimensional plane, 2D plane. Okay, 2D plane. So this works only for functions with for single variables. A function with single variable, right? It only works for functions with a single variable. It can be a quadratic, a cubic, but in all cases, these functions take in only one variable. So for that reason, they appear in only one plane. That's the either xy plane or any other plane. Okay, so it appears in so single variables, single variable or single variate. Let me make it single variate functions, right? They appear they appear on a single plane, okay? So whether it's x or any variable you use, so far as it's a single input function, it will be represented on a single plane. It can be a curve, it can be a straight line, or it can be any other thing, okay? But in the realm of multivariable functions, that is where you move to the concept where you have what three-dimensional plane, okay? So in this type of calculus, we are dealing with what the 3D plane. That is what you should take note. So three-dimensional plane. Okay. So here we are going to the x, y, and z plane. Okay. X, y, and z plane. So this is our z plane, and you have this to be our x plane, and you have this to be what our y plane, or you can make it any other. Okay. So you have your xy plane together for the z plane, and this we can have our xy plane here, we can have our xz plane here, we can also have our yz plane here. Okay, so these are some things you need to know as you are starting the multivariable calculus course. Okay, as you are starting the multivariable calculus cos. Okay, so let's see. Okay, so now let's move on to straightly talking about the domain of our multivariable calculus. Okay, our domain of our multivariable calculus. So let's see. So let me go domain, right? Domain of multivariate functions. Multivariate functions. Domain of multivariate functions. Okay. Okay, so let's see. What do we mean by domain when you say domain? So a quick recap on what a domain is before we go into domain of multivariable function. So when you say a domain of a function, okay, domain of a function simply means that all sets of what inputs that makes a function defined, that makes a function defined. Okay, so that is simply the definition for what a domain. So if you are talking about domain, then you mean that every set of inputs that makes a function defined. Remember that a function does receive an input. Okay, so when the function takes in the input, it processes it and brings out an output. But to get the domain of a function, we want a set of inputs that will make the function defined, or that will make our function what valid. Okay, we want a function, we want the set of input that will make our function what defined, right? Yeah, so what you do when you are finding the domain of any function is that we look out for what elements, or we look out for inputs, we look out for inputs that make the function undefined. So we look out for input that makes the function undefined. Okay, undefined, then you just take them out. So just look out for the input that makes the function undefined, then you take them out of what, of your set of inputs. Then we get your what, your domain of what, our particular multivariable function, right? Yeah, so now let's see. To get the domain of multivariable function, we apply the normal calculus one functions. We have different types of function. You have piecewise, you have stepwise function, you have constant function, algebraic functions, radical, trigonometric functions. You have so many types of function, right? So let's start from what the basic polynomial functions. Okay. So now let's take some examples so that you understand the concept of what domain. Okay. Let's take some examples. So now let's see. We have this. So determine the domain of each of the following function, of each of the following functions. So let's see. I'm going to give a series of functions. So when I give the function, then we find the domain in that order. Okay. So now let's see. I have f of xy is equal to the square root of what? X plus y. Okay. So now this is the first function we are going to consider. So we say determine the domain of each of the following functions. So this is our first function. So we say f of xy is equal to the square root of x plus y. So this is f of xy, meaning that it's taking in what, two inputs. Okay, so this is a function of two inputs, right? Then it's given us the square root of what, x plus y. So meaning that once we fill this function with the two inputs, what this function will do to the inputs is that in the course of processing, it will only take in what, the square root of what, their sum, and it will bring us a unique output what after computing this. Okay, yes, so what is the domain of this function? How do we find the domain of this function? So this is a radical function. Okay, so whenever you have a function under the radical sign, it's grouped under radical function. Also, radical function finds itself under what, the bigger umbrella, which we call what, power functions. Okay, a power function. So I have videos on that, so you can go and visit those videos and watch. So when you talk about radical functions, once you have the square root sign, right, you know that the square root sign receives what? Input which are what? Greater than or equal to 0. Is that not it? So whatever you put within a square root, right? Whatever you put within a square root, it should be greater than or equal to 0 before this square root can give us what? A valid output. Remember that though we have complex number, but in the course of multivariable function, we are limited to what? The real number domain. Okay, the real number domain. So let me say real numbers. So don't be convinced that the square root of what? Negative 2 is equal to what? Um, 2i. Is that not it? We don't accept this in what functions. The fact that we have complex numbers in functions, we are dealing with what? Real number system. Okay, the real number system. So we want everything should be defined under the real number systems, else this function become what? Undefined. Right. So meaning that the input within the square root sign should be what? Should be greater than or what? Equal to 0 for this function to be defined. Once you know that, then we can go ahead and find x plus y, as the condition says, should be greater than or what? Equal to 0. Is that not it? Yep. So once you have this expression, x plus y is greater than or equal to 0, right? So we can say that this whole expression. Now, in multivariable functions, don't confuse yourself. Is this the same as a single variable? Assuming that we had square root of x and we want to find the domain, you simply say that x should be greater than or what? Equal to 0. Is that not it? Yes, this is what we just say. And it's the same as this. So here, you just say that x plus y should be greater than or what? Equal to 0. So you can state the domain given us. The domain is given us. You say that a function xy is such that, right? Function xy is so that xy is a member of all real numbers, right? Where x plus y is greater than or equal to 0. As simple as that. So this gives us a nice domain. So xy, which is what? So that xy is a member of all real numbers where x plus y is greater than or equal to 0. And this is a perfect domain for our function. Do you get it? This is a perfect domain for a function, right? Somebody too can go the other way, and the other way says that we are to take everything that is what's undefined out of what our fun and our input. Okay, so what is going to make this undefined? So you know that when x plus y is less than 0, everything here will be what? This will be negative, therefore it will be undefined. So meaning you have to take this out. So somebody too can say that the domain is giving us what? A function xy is such that xy is what? A member of all real numbers except x plus y is less than 0. So whether you go by this or you go by this, they are the same. I mean, they are giving out the same information. One is giving us what x and y is, and one is saying that except, right, or except this, right? So they are all the same thing. Okay. So this is how we find the domain for our function. Now let's check another function b. So I have a function f of xy again, which is a two variable function. Okay. So let's start from the 2 before we move to 3. So this is equal to the square root of x, right, plus the square root of what? Y. So we have to find the domain of this function. So this looks similar to the first one we solved, but now they've been separated. Okay, so how or what's the difference between these two? So looking at this, we are still under the square root sign, right? So we are going to take them separately. We take them separately. Okay. So we know that for this function to be defined, the element under the square root sign should be greater than or equal to 0. Is that not it? So meaning that our x should be greater than or equal to 0, as well as our y should be greater than or equal to 0. Right? Yes. So once you have this becomes your domain. So x greater than or equal to 0, y greater than or equal to 0 is your domain. Okay, is your domain. So if you are to plot this, you know that if you have the xy plane, right, anything which is greater than or equal to x, right, which is greater than or equal to x is going to be what? This side, right? This side, this side. This is our positive x. Then this is our what? Our y. Is that not it? So our y is what? This way. So anything which is greater than or equal to what? 0, right? So x greater than or equal to 0. So meaning we are starting from the what? Origin 0. So anything on the right side of the origin, then the y2 like this. So realize that the domain is all the section, the intersection of this portion from here going. Okay, so this becomes the domain. Okay, sketching the domain. So meaning we can say your domain to yours. Domain is given us xy is that xy is what a member of what all real numbers where s is greater than or equal to 0 and what y is greater than or equal to 0. But simply put, some answers can demand only s greater than or equal to 0 and y greater than or equal to 0. Yes, it still tells you the domain of our function. So this is how we find the domain. Okay, so this is how we find the domain of our function. Okay, yeah. So now let's see our third question. So I have our third question to be given as a function of what xy is given as natural log of what 9 minus x squared minus 9y squared, right? So still on functions of two variables, let's see. To find the domain of this function, right? So to find the domain of this function, you ask yourself, what type of function do I have here? This is a logarithmic function. This is natural log of what? Of this whole thing. So you ask yourself, what are some of the things that makes a natural log or a logarithmic function undefined? You know that you don't have log of what? 0. It's not allowed, right? Neither you have natural log of what? 0. We don't have anything like that. Then we don't also take log of what? Negative numbers, right? So we don't have any log of negative real numbers. That one is also not allowed. So once you know that these are not allowed, then we can say that 9 minus x squared minus what? 9y squared should be what? Greater than 0, right? It should not be equal to 0, neither should it be less than 0. So you just say that this whole expression should be greater than what? 0, right? It should be greater than 0. So once you have this expression, you can what? Solve this. I mean, you don't need any simplification, but just arrange it in a nicer way so that it looks like any equation of what? Any geometric figure. Okay, so let's see. So this gives us x squared, right, plus 9y squared, right, is less than what? 9. Is that not it? Yes. So we can divide through by what? 9. Then we are going to get x squared over 9, right, plus 9y squared over 9 is less than what? 9 over 9. Is that not it? So this is the same as x squared over 9 plus y squared is less than what? 1, right? So this is a perfect equation of an ellipse. Okay, so we go through the spherical figures. Okay, we go through the spherical surfaces or the circular surfaces also in our later tutorials. So this is an example of what? An ellipse. Okay, so now let's see. So this happens to be the domain of the function, right? This is the domain of the function. So the domain is simply x squared plus 9y squared. Sorry, let me use the current one we had. Okay, so the domain is simply x squared 9 plus y squared is less than what? 1. Okay, so this is simply the domain of the function. This is simply the domain of the function. Okay, so this is it. So you can also put it like domain is given as what? Xy is that xy is a member of what? All real numbers where x squared over 9 plus y squared is less than what? 1. Okay, so you can put it in this way. Also accepted. Okay, so the same thing, let's see another one, our d. So this one, I have a function of x, y, and z. Okay, this is giving us 1 over the expression square root x squared plus y squared plus z squared minus 16. Okay, so we have to find the domain of this function, right? So this function is a rational function and having the denominator to be what? Having the denominator to be a radical function. Okay, so whenever you get such systems, even with calculus with single variable, you realize that whenever you have an expression which is a rational function, right, is in the form a over b, where b is not equal to what? 0. So meaning that the denominator here cannot be equal to 0, right? the denominator. So that's the first thing you should have in mind. The denominator should not be equal to 0, so that the entire function will be what? Will be defined. And also, when you come down, you realize that any term under the square root sign can be what? Greater than or equal to 0. Is that not it? So whatever, if a term is less than 0, then it means that it will be what? Undefined here. Is that not it? If a term is what? Less than 0, it will not make this square root what? Defined. Okay. So we combine these two conditions so that our whole entire b function should not be what? Equal to 0. And as well as whatever is in the square root should be greater than or equal to 0. So when you're merging this, you realize that when this whole expression becomes equal to 0, the function will be what? 1 over what? 0. Therefore, it will be what? Undefined. Therefore, we should have to remove this and it will be left with the what? Greater than. Okay. So simply, our condition becomes x squared plus y squared plus z squared minus 16 should only be greater than 0. It shouldn't be equal to 0. Once it becomes equal to 0, our function will still be undefined, right? But when it's equal to 0, our radical function will not be undefined, will be defined, alright, but it will affect the entire function as a whole. Okay, so we take 0 out. So our simple domain is simply equal to what? Is equal to x squared plus y squared plus z squared is greater than what? 16. Okay, it's greater than what? 16. So this is an equation of a sphere. Okay, it's an equation of a sphere with what? Um, a radius of what? 16. Okay, with a radius. Sorry, it's a radius of 4. So you get to know all this in our later tutorials. Okay, so we are only handling the domain. So when you see this is an equation of a sphere. Right, centered at the origin. Okay, yes, so you get to know this. So with a radius of what? 4, that is the domain of our entire function. So that's the circular. So if you have to draw this, you realize that you need to draw a sphere which will be centered at the origin, and the radius will only cut around what? 4. Okay, yeah, so that is how we do it. So let's solve a couple of examples again and see how you go. So let's see. So let's take another example. So let's see. We have our fourth function to be, let's say, our e to be equal to f of xy is equal to the square root of x squared minus 2y. So how do we get the domain of this function? So from what you have been doing, you've seen similar ones. Okay, you've seen similar ones as usual. Okay, so with this we simply state that what? Our x squared minus 2y should be greater than or equal to what? 0. Is that not it? Should be greater than or equal to 0. So we simply transpose this, you get x squared is greater than or equal to 2y. Is that not it? Therefore, our y will be less than or equal to what? X squared over 2. Right. So this represents the equation of a parabola. Is that not it? So it looks like the equation of a parabola. So actually, once you do quadratic surfaces, you get to understand the equation of the parabola. Okay. So for the domain is such that let's say x comma y is at that x comma y is a member of what? All real numbers, right? Where y is less than or equal to what? X squared on 2, and this is enough for our domain. Okay, this is enough for our domain, right? Yep. So now let's see more complicated domains. So let's see. I have f of xy is equal to 1 over x, right, plus the square root of what? Y plus 4 minus square root of what? X plus 1. So we have to find the domain of this function. So how do we do this? So here you have three pieces of the function. 1 over x, we have y square root of what, y plus 4 minus what, square root of what, x plus 1. Is that not it? Yes. So we want to find the domain of this function. How do we do that? So we need to take away input that will make this function undefined. That is the goal. You take input that will make this function undefined. So to do that, we first consider each piece. So for the first one out of x, what input of x will make this undefined? But remember that we have x here, then we also have what, x here. Is that not it? So these two x, right, they need to correlate. The value here, if it's making the entire function undefined, it shouldn't what affect what, the two of them should have values which will be superimposed so that any value you choose for x will not make the entire function undefined, not this one alone. Okay, so this is what you do. You know that for this function here, if you want this function to be defined, meaning that our x, sorry, so if you want this function to be defined, meaning that our x should be what, greater than or equal to, no, it should be greater than 0 instead, okay, because it's a denominator. So meaning that x should be greater than what, 0, so that this function will be defined, okay. Or you can say that x should not be equal to what, 0. That should be enough. Is that not it? X should not be what, equal to 0, right? So once you have this, we come to the second one. So you know that if you have x to be what, less than 0, and you know that when x here, when you come here, x, so for this side, x should not be equal to 0, right? This is the condition we've got. Or you can say that x is greater than what, 0, okay. But when you come to the second one, the second function, for the second function, what do we say about it? You know that y plus 4 should be what, greater than what, or equal to 0. Is that not it? Y plus 4 should be greater than or equal to what, 0. So this one, I can say that my y should be greater than or equal to negative 4 at all time, right? So this is a condition, okay. This is a condition. So we have got two conditions, separate conditions. Now let's consider our last part, right? So for the last part, I have square root of what, x plus 1. So for this one too, I need to consider element that will make this undefined. Is that not it? So to consider such element, then I think that my x plus 1, right, should be greater than or equal to what, 0. Is that not it? My x plus 1 should be greater than or equal to what, 0. And for that reason, I'll have x to be greater than or what, equal to negative 1, right? Greater than or equal to negative 1. So now we have three conditions. We are just here towards superimpose, or we are here towards merge. Is that not it? We are here to superimpose, or we are here to merge. So realize that one condition is saying that x should be greater than 0. Another condition is saying that y should be greater than or equal to negative 4. Then another one is saying x should be greater than or equal to negative 1. So one technicality about multivariable function is that sometimes you are getting different conditions, but how do you measure it to get a single condition, right? So you know that when you draw s is greater than 0, right? If you have s is greater than what, 0, meaning everything which is what, above what, so on the right side of what, our, I mean the right side of the origin, which is on the line what, s equals 0. Is that not it? So on the line s equals 0, you are taking the right side of it. Is that not it? So when you come to the x is greater than negative or greater than or equal to negative 1. So it's the two x which you need to what, merge for us to get a complete what, domain. Okay. So if s is greater than 0, meaning on the right of 0, and this one is saying is that s should be greater than or equal to negative 1. So we are going to look out for what, negative 1. Is that not it? Negative 1. So this one too is starting from negative 1 forward, right? So one is saying we should start from what, 0 and move. Sorry, not starting from 0, but we should move from what, the right of 0. The other two is saying that we should move from the right of what, negative 1. But you realize that when I put at the point s equals 0, this function is undefined. Is that not it? Though we are all moving right, but at this point it's undefined. So meaning that we always take the bigger one. Okay, we always take what, the bigger one. Is that not it? Or the farthest one on your left. That is what you take. Because once we start, anything here covers what, this already. So if I start my condition here, already this will be consumed. Is that not it? But if I start here, I will omit this. So if you want to have the complete domain, then you need to what, start from the farthest what, this side, then you move to this side as our condition. Okay. So meaning that for this side, I will only take s should not be equal to 0. Right, then I'll take this side, s should be greater than or equal to negative 1. So meaning s is starting from negative 1 to what, what positive infinity, is that not it? But x should not be equal to 0. That is all. So the discontinuity occurs at s equals what? 0. That is where the function becomes discontinuous. So we will write our domain as, our domain will be saying that we have xy, which is xy, which is a member of what, all real numbers, right? So that you have, maybe we can start from here, x greater than or equal to -1, x not equal to 0, and also y greater than or equal to -4. Okay, so this becomes what, the function, the domain of our function. Our xy is just a member of all real numbers, yes, all right, but our x is always greater than or equal to -1, our x is not equal to 0, then our y is greater than or equal to what, -4, right? Our y is greater than or equal to -4. So let's try representing this on the graph. Okay, so if you are to represent this on the graph, you realize that if I draw this, I have this as my x, I have this as my y, right? X equals 0, 0 is what? The y-axis, is that not it? So if you have line x equals 0, we are dealing with the x y-axis. So meaning the y-axis is not part of what? Our domain. The y-axis is not part of our domain. But our domain will start from what? -1 on the x side, all towards, so line x equals -1, which is like this, all to this, all to the side, to positive infinity. But the line what, s equals 0, is not part of the domain. Okay, it's not part. Okay, then remember that y is also starting from what, is greater than or equal to what, -4, greater than or equal to what, -4. So meaning that our line y, the y2 will start from what, -4 here. Okay, so that from -4 it moves what, it moves up. Okay, because what is greater than -4 will be -2, -2, -1 toward this side. Okay, so meaning that the entire domain spans from here, right? So let me use maybe I'll write here to be what, -1, then here becomes what, -4, right? So these are the boundaries of what, and here is 0. You know that 0, it doesn't what, become defined, right? You know that 0, our function doesn't become defined. So let's see. Okay, so let's see something here. Let's take one more question on domain, and let's see how we go by it. Okay, so let's continue from where we reached. So domain of a function is not difficult as you may think. Okay, so domain of a function is not difficult as you may think. So we are simply taking out what, element that will make our function undefined. Then we just remove them from what, the set of what inputs we want. Okay, so let's take one last question. That will be maybe our set question. Then we move on to what, limit of a function. Okay, so now let's see. Let's I have f of x, y, and z equals 1 over the whole expression x squared plus y squared plus 4z, right? So once I have this expression, I want to find the domain of this expression, right? So the domain of this expression here, to do that, I need to analyze the function and know element that will make this function undefined. This function is a typical rational function, right? Typical rational functions. So with a rational function, as you know already, element that will make a rational function undefined are element that will cause the denominator to be what? Equal to 0, right? So when I find x squared plus y squared plus 4z, right, is equal to 0. Whatever I get for x, y, z, they will be the element that will make this function undefined. And I need to take them out before I can get my what? My complete domain of the function. Okay. So therefore, my domain is simply what? X squared plus y squared plus 4z, right? Should be greater than what? 0. Is that not it? It should just be greater than 0. So this is actual the domain of this function. So x squared plus y squared plus 4z should be greater than what? 0, right? Should be greater than 0. So you can also do it this way, that when you solve this expression, what are you getting? So you can make z the subject. Okay, making z the subject, you are going to get something like what? Um, 4z will be equal to negative x squared minus what? Y squared. Is that not it? So z will be simply equal to negative x squared on 4 minus y squared on what? 4, right? So you can say that x is a member of all real numbers. So domain xy is that xy is a member of all real numbers except what? Z is equal to negative x squared over 4 minus y squared on 4, right? Or you can also say that x y is such that x y is a member of what? All real numbers, where x squared plus y squared plus 4z is greater than 0. So domain is very simple. Domain is very simple. Okay. So without wasting time, move straight towards finding let's move straight finding the what? Limit of what? A function. Okay. So how do you find the limit of a function? So let's see how we go by limit of a function. Okay, so limits of multivariable function, multivariate function. Right. Let's see. So first of all, what's the concept of limits? Right? Limits of a function. Limits of a function as a whole. So when you say the limit of a function, okay, the limit of a function normally represented as what? L. Okay. So when you say limit of a function, it means that whenever you are approaching a function, okay, whenever you are approaching a function through different parts, we will be getting that same what? One, right? So I mean, our function tends to give out a particular value. Okay, it's approaching a particular value whenever we are passing through different parts. Under that, we have what we call, so from calculus 1, we had what we call the limit, left hand limit, and what we call the right hand limit, right? That was in calculus 1, or calculus with single variable. That is where whenever you are on the whenever you are on the xy plane, okay, whenever you are on the xy plane, right? So if you want to approach any point, let's say x naught in our xy plane, right? You can only approach this point xy in the xy plane in only two dimensions, right? Either coming from what? The right side, or coming from what? The left side. So this gives rise to what we call the left limit and what? The right limit, okay? So if I approach this from the left side, then I'll say that I have a left limit. If I approach it from the right side, I'll say I have what? A right what? Limit, a right hand limit, okay? Then the condition was that our left hand limit, so let me say left hand limit should be equal to what? The right hand limit, okay? So the left hand limit should always be equal to the right hand limit for you to say that the limit exists. So whatever path you take, approaching this x naught, we should always get a particular what? Outcome y, which is what? A part of the function, okay? A particular outcome y somewhere, which always the answer you are getting will be approaching that particular what point, okay? And as you know, the word limit here generally means that what? The limit, I mean your limit, you can't exceed that, right? So all that we are trying to say is once you are approaching what this point from any direction, we can never exceed this particular point. That is the limit. Okay, we can't exceed this particular point, and that is the term of limit. Okay, so meaning that no matter the path you take. And I'm saying that in the xy plane, you have only two what paths, either the left or the right. But now let's come to multivariable function. So in the multivariable realm, this looks quite complicated a bit. So how do we handle that? So in a multivariable realm, one thing you should take note of is that we are dealing with the three-dimensional plane, okay? Three-dimensional plane. So we have our what? X, we can have Y here, then we have Z axis, right? So with this plane, assuming that I want to approach a particular point in space. So here we do with space. So this point may be point P, and the point P will have X, Y, and what Z, right? So this point P is what I want to approach this point. I can approach this point in infinite directions. I'm not restricted to what? Finding what? I'm not restricted to either left side or right side. For in this manner, you can approach this point from this side, from this side, from this side, from this side or any direction. You get it? You can approach it with different directions. So in multivariable realm, one nice thing is you can choose different paths, different paths to approach your function. But the condition is that whatever path you take, path you take, path you take, right? We should have the same answer. We should have the same answer, right? We should have the same answer. Okay. So as I was saying, whatever path you take, you should get the same answer after approaching this point as your limit. That is one thing you should take note of. Okay. So now, as I'm saying that you can have infinite directions to approach this point. So this here, we don't have left hand, we don't have right hand. It can be different points. Okay, it can be different points. So now let's see. Let's take some examples for us to what understand limits of what functions very well. Okay. Okay, so now let's see. First of all, let's talk about this continuity. Let me go hand in hand with what continuity. So let's briefly talk about the continuity here. So now we say that a function, right? A function is said to be what? Continuous. So let's say a function f of what? Xy. Let me use this as what our variable function. It can be fyz. Okay. It's said to be continuous, right? It's continuous. A function is said to be continuous at a particular point. Let's say AB. Okay. AB. If the limit as you approach the point AB, okay, the limit as you approach the point AB is the same as your functional value. Okay, so one thing you should also take note of is that if you approach your point AB of the function f of xy, right, and this is equal to the functional value of what AB, then you see that our function is what? Continuous. Our function is what? Continuous. So take note of that. Take note of that. Okay. So as I said, a continuous function is a function which has a limit value being equal to what? Its functional value. Okay. So in this manner, a discontinuous function will be what? Other way around. So for discontinuous function, discontinuous function, okay. For discontinuous function, you are going to have what? The limit as xy approaches what? AB, right? Of f of what? Xy. Not to be equal to what? The functional value of what? AB. Is that not it? So once this condition doesn't hold, once your limit is not equal to your what? Functional value, it means that our function is what? A discontinuous function at the point AB. Okay, there is discontinuity, right? So as I was saying that the continuous function will have the limit being equal to the functional value. So have this in mind as we approach solving some problems. Okay. So now let's see something here. So let's see our first example. So determine if the following limits, right, exist or not. If they do exist, then give the value of the limit. Okay. Okay, so I'm going to give a series of what function for us to go through so that you understand limit. Okay, so the preamble is saying that we should determine if the following function, if the following limits exist or not. If they do exist, give the value of the limit, right? So we are just determining if it exists or not. So remember the condition for a function to exist. The condition is that no matter the path you take to approach the function should what exist. Okay, so let's see. The first limit is the limit as x, y, z, right, approaches 2, comma 1, comma negative 1 of the function 3x squared z, right, plus yx cosine of the expression pi x minus pi z, okay, minus pi z. So once you have this, we are finding the limit as this x, y, z approaches for this point. So let me illustrate this to you. So assuming in this plane, right, I'm having a three-dimensional, but I've taken only one of the planes. So if I have a point here, right, x and y, a point in space can be approached with either a straight line, maybe here is A, here is maybe B, right? You can approach our point xy, okay, using the equation maybe y is equal to A or s is equal to B. You can also approach this same point using also this curve, right? Using this curve. You can also approach this point using this curve. You can also approach it using this slanted line. So whatever dimension you approach this point, it should also give us what the same limit value, right? So that is the key word here. So meaning that if I take different parts and this function doesn't what give me what the same limit, it means that the limit does not exist. And that is the part of what the first what we are doing. Determine if the following limit exists or not. And if they do, then it means that what our value is what the limit. But take note, from the continuous from the continuity we just solved, okay, I just explained to you, you know that a continuous function has a limit to be equal to what its functional value, right? So sometimes, in order for you to solve the limit of a function, just identify if the function is continuous. So if the function is continuous, right, if your function is continuous, then our limit will automatically exist, okay? The limit will exist, and also continuity occurs at a particular point. So the thing is, whenever they give you a limit value, okay, test whether the limit is what, sorry, the function is continuous at our point first before you go and start the limit. Because once the function is continuous at that point, meaning the limit exists, okay, meaning that the limit exists and it occurs at that particular point, okay, that is one thing you should take note. So always, as I'm saying, number one, find the what, test for continuity first. So if you want to find the limits, okay, if you want to find the limits of any function, so you just have to first test for continuity, okay, test for continuity, okay. So once you're able to test for continuity and the continuity is valid, okay, to test for continuity, all that I mean is that put your functional value inside. When you put your functional value inside and it gives us a defined output, it means that our function is continuous at this point, okay. And once it's continuous at this point, automatically the limit will be what equal to what the functional value, okay. So now let's see something here. Once they give us this problem, how do we approach this problem? So we can approach this problem simply by what? Finding what? The functional value first. If the functional value exists, then it means that our limit also exists and it was occurring at the functional value. But a case where our functional value doesn't exist, that is when there is a problem, meaning that our function here is not continuous, and for that reason, we need to what? Find the limit separately. The limit is different from what the functional value. Okay, so now let's see this problem first. So solution. So the first thing, we just have to put this point inside. Okay, that's all. That's all. So our limit will simply give us 3 multiplying what is x? X here is what 2, right? 2 squared multiplying z is what negative 1. Is that not it? So plus our y is what 1 multiplying x which is what 1. Is that not it? Sorry, s is 2. So x is 2. It's giving us 2. Cosine of the expression So 2 multiplying pi, is that not it? 2 pi minus what? Pi z, right? Pi z. And z is what? Negative 1. So minus pi. That's all. So when you simplify this expression, what are you getting? This is what? 4, 12. So negative 12. Then this is what? Plus what? 2 cosine of the expression. What is this? 2 pi plus pi. So cosine 3 pi. Is that not it? Cosine 3 pi. So now with this expression, you know that surely we are going to get what? A defined output. Surely we are going to get a defined output. So you simply take your calculator, then you punch this as we solve it together, okay, to verify all your answers, okay. So you just finding cosine of the expression 3 times. So if you don't want to use in the pi domain, okay, if you don't want to use a pi, you can punch 2 cos what? 3 times 180, okay, it should give you the same answer. So this is the same as negative 12 plus what? So when you punch cos 3 pi, you are getting negative 1. Okay. So this is going to give me negative 12 minus 2, which is negative 14. Okay. So now we are getting the functional value. Okay. The functional value to be equal to negative 14. So once your functional value exists, it means that our limit what exists. So we are saying that f of what? X, Y, Z, right, is what? Let me say a function. Let me do it this way. So let's write this way. So f of 2 comma 1 comma negative 1, right, is giving us what? Negative 14, right? So from the condition of what? Continuous. So we said that a function is what? Continuous if it's continuous at this point, right? If the limit value is equal to the functional value. So meaning that the functional value should be defined. Okay. So once the functional value is defined, it automatically equals what? Our limit. So there's no stress for you to what? Find your limit again. Okay. Your limit again. So in this sense, straight away we see that what? Our limit is equal to what? Our limit as x, y, and z approaches what? 2 comma 1 comma negative 1 is simply equal to what? Of the function f of x, y, z. I don't want to repeat this whole long thing. It's giving us what? Negative 14. And we're done. That is all. So first of all, the limit exists. Okay, it exists. And what is equal to negative 14. Let's check our second problem. So our second problem is saying that find the limit as xy approaches 5 comma 1, okay, of the expression xy all over x plus y. Okay, so this is our second problem. Let me isolate this. So now let's analyze our second problem. So in the analysis of our second problem, you realize that I have what here? Xy over what? X plus y, right? So with this that I have here, what am I getting? It's a rational function. Always take note, it's a rational function. Is that not it? It's a rational function. Okay. So once I have this here, then I'm going to have this. So it's a rational function. And I'm saying that once I have this quotient here, okay, once I have this quotient, I said the very first thing to do when you're finding your limit is what? Put your functional value in it to test for continuity. If you put and you get a defined value, it means that your limit exists and it's occurring at that particular value. The problem always arises whenever you put your functional value and it's what's giving you undefined. At that time, there is something called a discontinuity at that point. So meaning you need to what? Rearrange your what function, or you have to take different parts to find your limits. Okay, that is the only problem. So now let's see. First of all, let's find our functional value. So f of what? 5 comma 1 will give us what? Xy, right? So 5 multiplying 1 all over what? 5 plus 1. And what are you getting? 5 on what? 6. Is that not it? 5 on 6. So once our function here has been the functional value to be equal to 5 on 6, you just don't need to worry. Okay, you just don't need to worry because our function here is what? Continuous at this point. Our function here is what? Continuous at this point. For that reason, you simply say that the limit what as xy approaches what? 5 comma 1 of our function f of what? Xy is simply equal to 5 on what? 6. Okay, function is equal to 5 on 6 and the limit exists. Okay, so test for continuity. If continuity or if continuity at the point was 5 1, that is function finding your functional value is true or is valid, then it's automatically your limit value. So let's go ahead and solve some different problems. So it may not always be easy as you are thinking, okay? You can get some better problems along the way. So let's see. So now let's see this problem. Limit as, let me take this out. Limit as xy, right, approaches what 1 comma 1, okay, of the expression 2x squared minus xy minus y squared, okay, all over x squared minus y squared, okay. So now we are finding the limit as this function approaches what, approaches 1 1. So as I said, always find your what, f of 1 1. So what's my f of 1 1? I'm getting the expression 2 multiplying 1 squared minus 1 multiplying 1 minus 1 all squared, right? All over the expression 1 all squared minus 1 all squared, okay. So this is giving me what, undefined, because I'll be getting here to be what, 0. If this is 0, the whole thing will be undefined. So in this manner, our what, f of what, 1 1 is what, discontinuous, discontinuous at that point. So meaning that our function is continuous at what, point 1 1. So at this point, there is a problem, right? There is a problem. So how do you modify our function to eliminate this discontinuity? So meaning that right now we can't say that the functional value is undefined. So meaning our limit is undefined. No, okay. The vice versa is not true. So in this manner, we handle this to remove any undefined, or I don't know, any discontinuity out of it. So how do we do that? Let's see. You have 2x squared minus xy minus y squared, okay. So once you have this, all over x squared minus y squared, is there a way to simplify this expression to remove what, our discontinuity? Oh yes, we can, right? We can do this, okay. So you can see that this becomes a quadratic, which we can what, separate. Is that not it? Yes, we can separate this, we can separate this. So this is equivalent to 2x plus y multiplying what, x minus y, okay, all over this differences of t squared, x minus y, x plus what, y. One may wonder, how did we express this into this form using the quadratic? So 2x squared minus xy minus what, y squared. So how do we decompose these two? How do we decompose these two? You know that the coefficients of this xy was negative 1. So if I want to separate this negative 1, how do I do it? I can make something like 2x squared, right? So this is negative 1, right? So negative 1, I can do something like minus um negative 1, I can do something like minus 2xy plus what, xy, right? Minus y squared. You are just trying to decompose our function so that we can get a simplified what, factorization. So once you do this, you just circle this here. It's just a manipulation, okay? So you know that when I add it, I'll get this back again. So here I'll factorize 2x out, right? And I'll get what, x minus y. Is that not it? Here I'll factorize y out, okay? Then you get what, x minus y. Is that not it? So you get 2x plus y, then we get what, x minus what, y, okay. So once I have this expression, that is what I have here. You can clearly see that 2x plus y, x minus y, this can take this off, and our function will be reduced as 2x plus y all over the expression x plus y. At this point, when I apply my limit point xy, where xy is given as 1 1, what am I getting? I'm getting 2 multiplying 1 plus 1 all over 1 plus 1, and this is giving me what, this is giving me 2 times 1 plus 1 is what, 3, right? I'm getting 3 over 1 plus 1, which is what, 2. So I'm getting 3 out of 2. So therefore, my limit for carrying at this point is what, 3, 2. So this is a typical example of what, situations where your function will be discontinuous at a particular point you want to find a limit. Therefore, there should be adjustments to the function so that we can take away the discontinuity at that point. Okay, so this is a typical example of what I'm saying. So now let's see something here. So at this point, let's get more problems so that you understand this concept better. So let's up. So now let's see another problem here. So we solved how many problems? 3 so far, right? So we solved 3. So let's have fourth one. So let me write our D. So our D, we are having what? Limits as xy approaches 0 0 of the function x squared y squared all over x to the power 4 plus 3y to the power 4. Okay, so once I have this expression, say we should find the limit. So let me take this away. He said we should find the limit as x approaches 0, 0 of x squared plus y squared all over x to the power 4 plus 3y to the power 4. So as usual, what do I say we should do? As I said, find the functional value, okay? Once you find the functional value and it's still not working, then we try to adjust our function. If not, let's see. So let's see what you can do to this function here. So first of all, what do I do? The first thing I'm going to do is to find the functional value. For functional value, that is f of 0, 0 is simply equal to, I'll have 0 squared multiplied by 0 squared all over what? 0 plus what? 3 multiplying 0 to the power 4. And obviously this is what's undefined. So once it's undefined, I'll say that my function is discontinuous at what? This point 0, 0. For that reason, my limit value will not be equal to the functional value. For that, and I have to adjust my what? I have to massage my main function to get my what? My limit. Okay. So to do that, how do I do that? So I simply have x squared y squared over x to the power 4 plus 3y to the power what 4. Is that not it? X to the power 4 plus 3y to the power 4. So having something like this, you get to know that having something like this, okay, can we simplify this to get rid of the discontinuity? No, the functions here are complicated. So this way we do something, we take parts. We take parts, okay? So take note of this, we take parts. So part means that we are taking different routes to approach this function. Then we find the limit at that point, okay? So the condition is that irrespective of the path I take, I should get the same answer at all points, okay? Irrespective of the path I take. So you can take a path like y equals 0, that is, you are taking the x-axis, okay? Or you can take x equals 0, you are taking the y-axis, okay? You can take y equals 6, a line through the origin. You can take different dimensions. You can even take y is equal to s squared is equal to s cubed, like any dimension you want to take. But the condition is whatever part you take, you should arrive the same answer after finding the limit. So now, this is what you're going to do. You're going to take our first part. So first part, okay. So the first part will be when y is equal to 0. So when y is equal to 0, what do I get? I'm going to get an expression of what? S squared multiplying 0 all squared all over x to the power 4 plus what? 3 multiplying 0 to the power 4. Okay. So this gives me what? So realize that when we take the part y equals 0, obviously here will be 0 and we're getting 0 over what? X to the power 4, which is 0. So when I take limits as x approaches 0, now it's a single variable, take note. So single variable as it approaches 0 of the function what? 0. So let me put the function here 0. This is a constant function. So if you have a constant function, irrespective of what the limit point, you will always get the constant output. So here will give me what? 0. So the limit when I take the part y equals 0 is giving me 0. Now let me take a different part, right? So I'll take a different part. And the part I'll take is when s equals 0, right? When s equal to 0. So when s is equal to 0, then what am I getting? Obviously, I'll get 0 squared y squared over 0 to the power 4 plus 3y to the power 4. Okay, so this gives me 0 over 3y to the power 4. Okay, and obviously this giving me 0. So the limit as y approaches 0 of 0 gives me what? 0. Okay, so now I've taken two parts. I'm getting 0 in all cases. Okay, I'm getting 0 in all cases. So now, should I be convinced that this function is indeed having a limit of 0? No. You took x equals 0, y equals 0. They look similar, right? So you have to take something away and see. So now we can test for the last words. We can test for the last. So the last is maybe you can take the part y is equal to x, y equals x. So always at least 3 should be enough. 3 parts should be enough for you to confirm. So taking the line y equals x, what am I getting? Wherever I see y, I put out x, right? So from the main function, I have my main function to be s squared multiplying x squared because the y will be x, okay, all over x to the power 4 plus 3 multiplying x to the power 4. So this gives me x to the power 4 over x to the power 4 plus 3x to the power 4. This is the same as x to the power 4 over 4x to the power 4, right? So meaning that obviously when I cancel, I'm getting what? 1 over 4, is that not it? So the limit as x approaches 0 of 1 over 4 is simply equal to 1 over 4. This is a constant function. Now, the same function, we approach it with y equals 0 and we have 0, right? The same function, we approach it with x equals 0, we have 0. Now we approach it with what? Y equals 6 and we are getting 1 over 4. So since 0, we are getting 0, 0 and what? 1 over 4. They are not equal. These two happen to be equal, but the last one what? Became what? A different answer, meaning that our limit doesn't exist. Okay, it means that therefore you see that the limit doesn't exist. Okay, the limit doesn't exist. So this is the answer. The limit doesn't exist. Okay, so once the limit doesn't exist, you've seen how we've taken the different parts. Okay, so now let's take another approach. Sorry, let's take another example. So this example happens to be our what? So this was our fourth, right? So let's take our fifth example. So for our fifth example, I'm giving an expression here. So I'm having x cubed y all over x to the power 6. Let me write it all here down. So you let me write it somewhere else. Okay. So let me take this. It's not coming. Okay. Okay. So let's see. I have the limit, right? As xy approaches 0, 0 of the function x cubed y all over the expression x to the power 6 plus y squared. Okay. So let's see how you're gonna do this right here, right? Okay. So to solve this problem, as usual, you need to find your functional value at the point 0, 0. Okay, so our function of 0, 0, what are you getting? You are simply getting 0 cubed multiplying 0 all over 0 to the power 6 plus what 0 squared. And this obviously became what's undefined. So we have got another situation where our function is what? If no, the meaning that we need to take part. So right now you see that you have. How do you take parts? So right now, taking parts, I'll take my first part line y equals x. So if y is equal to x, my function becomes what? Wherever I see y, I'll put x. Okay, I'll get x cubed multiplying what? X, right? All over x to the power 6 plus what? X all squared. Is that not it? So this is the same as what? I'm getting x to the power 4 over x to the power what? So you have x to the power 6 plus x to the power what? 2. You can't add them. They have different powers. You can't just add them. So plus x squared, right? So once you have this expression, what do? The next is to take the limit, right? As this expression approaches what? 0. So the reason why we take part is to convert our multivariable to what? A single variable, right? So taking this, you just find the limit as x approaches what? 0. Okay, limit as x approaches 0, where you have what? X to the power 4 over x to the power 6 plus what? X squared, right? So what do? I simply what? Solve for this here, right? So I'm solving for this expression. How do I solve this? I want to find the limit as my x approaches 0. How do I do that? You know that this expression here, I can factorize the squared out, right? So with this, I can remove the discontinuity here. So I'll have x squared multiplying x squared. Is that not it? All over x squared out x to the power 4 plus 1. Right. So with this, I can cancel my x squared and x squared, and this expression becomes x squared over what? X to the power 4 plus 1. Then here I find the limit as my what? X approaches or 0. So wherever I see x I put at 0. So I have 0 squared over what? 0 to the power 4 plus 1. This gives me 0 over 1, and it's obviously giving me 0. So when I took the part y is equal to x, right? This is the part I took. I had my limit value to be on 0. So meaning I need to take another part, okay? Once I take another part, I'll confirm. I'm supposed to get the same answer if indeed the limit exists, right? So which part am I going to take? So taking another part, let's say line y is equal to s cubed. So I'm taking a quadratic, sorry, a cubic function as my part. You can take any part, okay? And I said always, if you take different parts, your answer should be the same before you can say that the limit exists, okay? Yeah. So right now, as I'm taking y is equal to s cubed, what am I doing? I just need to put it in my function. Wherever I see y, I put s cubed. So I'll have this is my function, remember? So I'll have s cubed, right? Multiplying s cubed all over x to the power 6, right? Plus, open bracket, s cubed all to the power squared. This gives me x to the power 6 at the numerator, x to the power 6 plus x to the power 6, right? So obviously, this gives me x to the power 6 over 2x to the power 6, right? So x to the power 6 cancels, and what am I getting? 1 out of 2. So if I'm to find the limit as what? So right now I'm having function in terms of x only. So as x approaches or 0 of 1 out of 2, this obviously gives me what 1 out of 2. Remember, it's a property of limit. So the limit of every constant function is equal to what? The constant output, irrespective of wherever you're approaching it. Okay. So now I'm getting 1 out of 2, I'm getting 0. So 0 is not equal to 1 out of 2. Therefore, limit doesn't or does not exist. Limit doesn't exist. So you realize that limit of a multivariable function is an interesting what concept, right? It's an interesting concept which you should be able to find, which you should be able to find. So we have gone through a lot. We've gone through a lot here. So we've gone through a lot. So let's see. So as I said, this particular tutorial was focused on what limits as well as the domains of what multivariable function. So I would like to end in this lecture, then hope seeing you in our subsequent lecture. So we are going to cover the whole course, okay? So this is just the introduction to it, right? So we handle every part of it, and don't forget to watch this video to the end so you get the understanding, and please follow up as we move on through the later part of what of these tutorials, and you'll be solving questions as well. So this was sponsored by GAD, right? GAD Academy, right? So he's an aspirant for GISA president, right? So GISA presidential position. So don't forget to show some love by just voting for him when the time is due. Okay. So until then, it's bye for now. Bye bye.